the next little piece of this puzzle is what happens when we consider differing values for what b is allowed to assume, and then how does that manifest itself in the graphs of these things. So we have f of x is equal to b to the x. Now, and then once we have this, then we'll take it back and talk about that in terms of our more important one, e to the x. So now we're relaxing. We're saying choose anything we like for the value of b. The base can be anything. All right? The restrictions are it's going to be bigger than 0, not equal to 1. I want on my number line down I've drawn down here, I want us to represent, if we wanted to sketch out a graph of the numbers that meet these requirements, it's got to be bigger than 0, so we do not want stuff out here. Bigger than, not equal to 0. Now, imagine if this were the only requirement. If this were the only requirement, then we would want all those numbers, all those values bigger than 0. But there is one extra requirement. We're also not allowed, we got to throw out 1. A way to represent that is we got to throw out 1. So anything bigger than 1, anything between 0 and 1, but not including 1. So we want to include all of this work, or all of this region, and then all of this region. But do not include 0, do not include 1. Now, I've broken this into two pieces. This is the part between 0 and 1. That's case 1 I have up here. And then case 2 is anything bigger than 1. So anything beyond 1, that's out here in this piece. Anything between 0 and 1, that's here in this piece. This piece we've already discussed before. That was when we did our 2 to the x and 5 to the x and 10 to the x and yes, e to the x. The graph, roughly speaking, looks like this. And we also remember, all of these graphs of this variety pass through that point, 0, 1. Now, we have not graphed any of these. If you did, this is what would occur. It would still pass through 0, 1, just like this passes through 0, 1. But whereas this skyrockets up, this is like you're coming in for a landing. These, again, are just representations, general rough sketches of representing what's happening in each piece. Let's see if we can convince ourselves this is happening. What is the function value of 1? Let's pick a number here. Suppose we use, let's pick a specific number, something easy to use. Let's use, give me a number between 0 and 1. Is it clear? How about if we do f of x? Let's use the decimal value, 0.5 to the x. When x is 1, what's 0.5 to the first power? Well, 0.5 to the first power is 0.5. So 1 comma 0.5, or 1 comma 1/2. All right? But what is, so if x is 1, 0.5 to the x is 0.5. But with my trusty, dusty calculator here, what is 0.5 to the second power? That's 0.5 times 0.5. That is 0.25. It's half of that. Every time you multiply by 0.5. So that is to say, every time you're multiplying by half. This is actually a half. This is actually, do you see this? This is a fourth. So 2 comma 0.25. What about 3? You multiply by that again, times 0.5 again. That's 0.125. So by 3, it's only at 0.1. So what's happening is, as x gets larger and larger, this function value is getting smaller and smaller. Now what's happening on the negative scale is, remember, on the negative scale, it's the same number, but it's the reciprocal. And so it's not too hard to convince yourself, and you could plot as many of these points as you would care to. But it is in fact the case that for any value of b between 0 and 1, this is the general picture. This is the general sketch. Now, for any value greater than 1, this is the general sketch. We call this in many circumstances, this can be, we call this, or we use this to represent what's called exponential growth. Exponential growth. Whereas this is called exponential decrease. Or exponential decline. It's strictly speaking, it's also exponential growth. It's just negative growth is decrease or decline. So we have an exponential growth and exponential decrease. Both of these are exponential functions. So e to the x, of course, falls into this category, the graph of e to the x, which is roughly speaking like that. All right? For our purposes, that is sufficient. Notice that in both of these scenarios, the horizontal line test succeeds, which means both of these functions, in fact, all functions of this type have an inverse function, and that's where we're going to be going with a lot of this.